Our last presentation for this morning's session is Professor Rebecca Ahmed. She's doing the Novo Nordisk presentation today on metabolic and physiological changes in dementia and the potential role of GLP-1 receptor agonists. Professor Ahmed, she's recently professor, is a staff specialist neurologist at RPA and the University of Sydney, where she directs the multidisciplinary memory and cognitive clinic. She's done a PhD on eating and metabolic abnormalities in frontotemporal dementia and amyotrophic lateral sclerosis. She's a clinical scientist with her research focusing on metabolic biomarkers and neurodegeneration. So thanks, Rebecca.
Thank you for the opportunity to present. So the reason for today's talk is really to give you an idea that maybe there are treatments out there apart from amyloid. So these are my disclosures. And I came across this article which talks about how we focus on amyloid, and I mean no disrespect to the previous two speakers, but I think we do need to look outside amyloid. Amyloid does play a role, but we need to look, are there other treatments that we can look at as clinicians to help solve the problem of Alzheimer's disease and other neurodegenerative conditions? So my research is really focused on the fact that neurodegeneration is far more complex than just being a motor or a cognitive disorder. It affects other parts of the brain and causes other symptoms, including metabolic changes, changes in eating, autonomic function, pain, and sleep. And central to those changes, we've found that a structure in the brain is heavily involved across neurodegenerative diseases, which is the hypothalamus. And this is a small structure that has, I guess, a large punch, because it connects to other areas of the brain that are particularly involved in reward pathways and also has a function in memory. And we've shown in our research, particularly in frontotemporal dementia, but also motor neuron disease, that there is extensive atrophy of the hypothalamus, and there are changes in metabolic hormones that control both sleep and eating and metabolism. So that really brings in, where does GLP-1 fit? So GLP-1 is a peptide that's essentially formed from the breakdown of proglucagon, and it's made by the L cells in the alpha cells in the pancreatic islet cells. And essentially it has a broad function, including enhancing insulin release, inhibiting glucagon release, slowing gastric emptying, and reducing appetite. And everyone would have heard of the GLP-1 agonist drugs, Ozempic, and all the celebrities are on it, but it has a much more important potential function in terms of neurodegeneration. So the GLP-1 physiology, where is these receptors located? So they're located throughout the body in both the stomach, the kidney, the brain, etc. And they have broad kind of actions. So you think, oh, it's just appetite, it's just a weight loss drug, but it's far more than that. It has effects in the kidney, the cardiovascular system, effects on blood vessels, but also particularly on the brain. And my fellow asked me the other day, should we have invested in Novo Nordisk decades ago? And potentially, I think this might be a kind of potential life-changing drug for many patients, not just for weight loss. So the GLP-1 receptors are located throughout the brain, particularly in the nucleus tractus. And this, we'll go to the next slide, shows you the areas of the brain where it's located. And particularly, it's very located in the hypothalamus, but also in other structures of the brain that we know are related to reward function. And this will make sense to you when I talk about that potentially GLP-1 receptor agonists may also have a role in addiction medicine, which is an emerging area of research. So where did GLP-1 come from? Well, in 1992, Dr. John Ng discovered that there is a monster called the Glaya monster, which is found in the deserts of the Americas, and that can eat up to half of its own body weight in one sitting, but its blood sugar level remains stable. And that led to the concept that he discovered that there was an exopeptide in the saliva of this monster, which he named exidin 4. And he discovered that that really had a similar structure to human GLP-1, but it was much more stable, and that led to kind of the evolution, and there's lots of story in between that of these GLP-1 agonists. And so since then, since 1992, there have been different forms of the drug that have developed over time, and not all of these drugs are equal. They have different secretion, different access to the brain through the blood-brain barrier, and different dosing regimes. But this is an area that's active research from different companies that potentially has the action to act in neurodegeneration. So what I wanted to talk to you about now is what is the role in neurodegeneration? Well, we know that there is genetic variation in GLP-1 in humans that's been associated with an increased incidence of Alzheimer's disease and also Parkinson's disease. And that's been correlated to also changes in disease biomarkers, including amyloid and tau and neurofibrillary tangles. Most of the evidence we have available is from preclinical studies, but there are emerging clinical studies, and Novo Nordisk is about to read out on its phase 3 clinical study. But what the thinking is potentially that these drugs have a role in brain energy homeostasis, also in synaptic function, particularly also in neuroinflammation and cellular stress, also protein aggregation, and also potentially in the blood-brain barrier dynamics. So this is a really good review, and I didn't expect you to read the table, but what it shows is that there are emerging studies, both preclinical, clinical, and observational studies, all showing that potentially GLP-1 drugs do have an effect in dementia in terms of slowing the onset of dementia. So these are the drugs for mild cognitive impairment, and these are the studies for Parkinson's disease. And I just wanted to focus on these meta-analyses that they've done in dementia, where they've pooled studies to say, do patients who use these GLP-1 drugs for other things like diabetes, for example, have a delayed onset in dementia and Alzheimer's disease. And what you can see from 3 out of the 4 meta-analyses were positive, showing that these drugs did potentially slow the onset of Alzheimer's disease. So there's a growing evidence in the different forms of the GLP-1 agonists that they can potentially slow the onset of Alzheimer's disease. And those are in studies that have been both directly looking at it in Alzheimer's disease, but also looking at much larger studies where they've trialled the drugs in obesity and type 2 diabetes. So I think there probably is something there. So the next question is, how do these drugs potentially act to slow the onset, particularly of Alzheimer's disease? And there are 4 kind of proposed mechanisms of how they do that. The first is obviously an endocrine metabolic action, reducing insulin resistance and acting on the endocrine models. The other one is neurobiological, so acting on synaptic function. The third one is the gut-brain axis, which I think Professor Merriam might be talking about later. And then the last one is immunological, so acting on the microglia and inflammatory action in the brain. And so that's really where it's felt potentially that GLP-1 receptor agonists may have their mode of action in terms of acting on inflammation. And so it's hypothesized that they may reduce inflammation and also reduce the accumulation of tau, and by that way stop the progression of particularly Alzheimer's disease and have its neuroprotective effects. There are also potential preclinical studies as well that suggest that GLP-1 receptor agonists may have neuroprotective effects in the deeper brain structures and somehow affect the hippocampus and also the cortex and somehow turn off inflammation. And these at the moment are just preclinical hypotheses, but there is emerging data that they could potentially have a role. So this is a summary slide that just shows you potentially how we propose or think that these drugs may slow neurodegeneration. So essentially they may promote homeostasis in microglia and astrocytes, reduce immune cell recruitment, reduce systemic inflammation, potentially reduce oxidative stress, increase the blood-brain barrier integrity, and have a positive protective effect on neurons. And the hypothesis is that this potentially slows neurodegeneration. The other kind of, I guess, take-home message from all the studies as well is that some people might say, well, we've been told to reduce our vascular risk factors and our risk of diabetes, and that's potentially how they have their effect of slowing neurodegeneration and the onset of Alzheimer's disease. But when they've looked at the data from the type 2 diabetes studies, essentially the effects of the GLP-1 receptor agonists on slowing neurodegeneration onset of Alzheimer's disease was separate from glycemic control and body mass index control. So it's not just about stopping diabetes and losing weight. It somehow has some effect on the neurodegenerative process and inflammation. So there are lots of studies at the moment going through semaglutide about potential effects not only in Alzheimer's disease but other conditions. So it really is a hot topic, not just in the media but also in research. And I guess the most exciting thing for Novo Nordisk is their EVOKE studies, which I think there are several investigators in the audience, but at the moment they've got 2 trials that are running. The EVOKE study looking at people with early Alzheimer's disease, and also the EVOKE Plus study where patients were allowed to have signs of vascular disease, which is often an excluding factor from other clinical trials. So I guess it's looking more at real-world populations because most patients do have some vascular disease. And they're essentially trialling the studies in different dose levels and looking at the effect on the key markers that we look at in all clinical trials to see, does it affect the CDR and the rate of progression in Alzheimer's disease. And I understand the results are due at the end of October, so it's close. So I think we'll wait with interest the results of those studies to say, is there an effect in phase 2 directly in patients with Alzheimer's disease? And so these are the sites that are running the trial in Australia. The other point I just wanted to make at the end of my talk is these are the studies that have been done in addiction medicine and cannabis. So they do exist, and a lot of them have a positive value for outcome for GLP-1 receptor agonists. So I think that's another area of emerging research about how these drugs might help people with addictions to overcome those addictions, and also some emerging data that's not as positive as the other studies for both anxiety and depression. So I think they're kind of take-home messages. So my take-home message is creative ideas come to the intuitive person who can face up to the insecurity of looking beyond the obvious. So I think we need to look beyond our amyloid and at other therapies that may have a role. Thank you.
Thanks, Rebecca. Any questions? Michael and then Bruce.
The story is very convincing, and I fully agree with it. If the EVOKE studies are negative, are you going to blame the study, or does that disprove the hypothesis?
I don't know. I'm hoping it's positive. And I mean, I think we need to look kind of closely how close it is, kind of what the data looks at. So I guess I'll comment when we get the results. But I mean, I think there's enough preclinical data there, and I think we have to keep trying.
Bruce?
Thanks. How do you explain the obesity paradox for elderly people who are a little bit overweight? Is that just a statistical artifact, survivor bias, or because the data are pretty strong?
What do you mean, like saying they're overweight and...
So in the elderly population, if you're overweight, dementia risk is reduced.
Yeah, and I mean, that's a thing, and I've looked extensively at that in, for example, my FTD research, where you find that people who are overweight tend to do better in terms of their prognosis. And we found that in both FTD and motor neurone disease. And our hypothesis of how that might work is there's a sweet spot where if you can manage the obesity, you can potentially stop the onset of the disease. But once you've got the disease, our studies have shown that your metabolic rate does increase. And so being a bit overweight is protective. So I think there's kind of a sweet point where, rather like with tau, once you've got the tau, it's too late. So that's potentially an explanation.
Yeah, just I'm curious. I mean, obviously, it's really interesting and very exciting data. There's a lot of people who have had these GLP-1 agonists around the world, but the amount of time that each individual's had it is pretty limited. So, I mean, knowing that we're dealing with a long-term chronic disease, do you have any concerns about the long-term effects?
I mean, I guess that's a good question, and I think we have to wait the results of the phase 3 trials, and then I guess the result will be for the drug companies then to plan studies looking at the kind of long-term outcome and following them up long-term to see what the side effects are and kind of how they do long-term. So I don't think we have the answers, but this is a start.
No? I think you've answered all the questions. Thanks, Rebecca. Just a disclosure, I'm the Australian rep for the Evoke trial, so yeah, there is top-line results at CTAD, but there's still another year for the trial to continue, so keeping patients on that trial may be difficult if it's negative, but we're hopeful. Anyway, we have an early mark for lunch time, but before you go to lunch, just a few announcements. We'd like to, again, thank our main sponsors, Lilly, Eisai and Novo Nordisk. This is a message from the Lilly team. There is a scientific exchange meeting on the 1st and 2nd of November at the Sheraton Grand, which is just across from Hyde Park, I think. So there are flyers for that. There are still spaces available, Miriam tells me. That's right. So see the Lilly team and you can register. So there's lunch till 1 o'clock for Dementia Trials Australia members. For our pharmaceutical and sponsors, we just wait 15 minutes for the AGM, and then everyone can come in for the second session, which Dr. Kathy Short will chair. So please enjoy your lunch. It's at the restaurant, at Barker's Restaurant. So thank you, everyone.